Right, it's my great pleasure to introduce to you Dr. Bodo Winter, who is a senior lecturer at the University of Birmingham in the Department of English Language and Applied Linguistics, I think it's called, isn't it? And he is, Bodo did his master's on Hawaii. Not on the topic of Hawaii. He obtained his PhD from the University of California at Merced, and he then came to the UK, to Birmingham. He is a general editor of Language and Cognition, has written a lot of interesting papers and 2 books, as far as I know. He is an expert in statistics, particularly in Bayesian statistics, and teaches the according crash courses, summer schools, and whatever you name it, and publishes extensively on them. Bodo won the Future Leader Fellowship from the UKRI, and therefore he's one of the richer people in his department, I guess. The project started in April, and we're all looking forward to hearing about the things you're doing. Please join me in welcoming Bodo Winter.
Great, thank you. Thank you for that very nice introduction, Peter. And thanks to the organizers for having me here today. And thanks for everybody who's in the room. And I'm really excited to have this opportunity to do this talk, which is going to be about 40 minutes. And brace yourself. I have packed it chock full with, I got very excited when I composed these slides, but I'm going to time myself so that we have enough time for questions. Okay, so I want to talk today about iconic gesture, and specifically iconicity more broadly, because the way I think about iconic gestures and iconicity in speech, they're sort of fundamentally the same process. And to set the scene, what do I mean by iconicity? In sort of standard semiotics, which looks at the study of signs, the standard distinction is between arbitrary signs, indexical signs, and iconic signs. And when we think about this, we have to think about how does the form of a sign, such as an English word, connect to its meaning. So for example, the English word tree, we have to distinguish between form and meaning. And it doesn't seem to be anything tree-like about the sounds t, r, and e. It seems to be a fairly arbitrary collection of sounds. And that becomes apparent when you're looking across languages. So my native language, German, Baum, has not a single sound overlapping with tree, yet it means the same thing, making it seem as if different languages sort of assign meanings to speech sounds arbitrarily. Indexical signs and gestures are those that establish a meaning, for example, through pointing by having a direct spatial connection, some sort of causal, temporal, spatial contiguity. And then iconic ones, those are the ones that I'm interested in today, both in speech and in gesture and in sign, are those that depict where the form resembles aspect of the meaning. So for example, onomatopoeias like cuckoo, that sounds like actually what the bird sounds like. There's a direct mimicry, and form resembles meaning. And this happens across modalities. So it's independent. These semiotic principles are fundamentally independent. There are different ways of making meaning that exist regardless of whether we're using our hands or whether we're using speech. So the ASL sign for tree is actually iconic because it mimics aspect of the meaning. And so I'm going to focus on arbitrariness versus iconicity here, which is sort of the standard, they're like each other's enemies. And iconicity is sort of the villain here, because the standard dogma in linguistics is that the linguistic sign is arbitrary. In particular, when it comes to spoken words, the idea is that most things do not sound like what they mean. Most words are like tree and Baum, and very few are like cuckoo, which are supposed to be the exception. Now, I very briefly want to talk about spoken language iconicity before I talk about gesture. But just to sort of give you a flavor of the type of work that we have done across different modalities. So on spoken language iconicity, we're interested in showing that there's a bit more iconicity than researchers have thought about in the past, given that Saussure and other sort of founding figures in linguistics have said language is mostly arbitrary. So to give you one example of a paper, size sound symbolism in the English lexicon, we looked at words like large, huge, colossal, jumbo, vast, whopping. And if you even just listen to the sound of those, they sound, I would argue, bigger than little, meager, midget, itsy bitsy, slight, puny, and petite. And what we did in this study is to look at the phonemic structure. So is a particular sound present or not? And can you predict from this whether the word is a synonym of small or big? Using, like we can talk about in the paper, I'm just giving you a flavor of this research. We're using random forests, a machine learning algorithm to basically predict meaning from sound for etymologically unrelated adjectives. And it turns out that this works really well with 77% accuracy for adjectives that the algorithm hasn't seen. So this is for unseen new cases. And so there is meaning in the sound structure. Interestingly, this will become relevant when we look at gesture later. If you look beyond size adjectives, which are specifically about size, what happens if you look at words that just happen to be large or small, but they're not just about size? Like, for example, grasshopper is a small thing, universe is a big thing. And if we run the same analysis trying to predict size for a larger set of things that are not size adjectives, we're much less accurate. And that will be something that we'll see later in gesture as well, which is that iconicity, resemblance, is always resemblance of something specific. And you will only find iconicity when you're looking in the right corners of the lexicon or when you're looking at the right gestures. Just one more study that I wanted to highlight. We have done similar analysis of other perceptual domains, so not just size. So how does form mimic, for example, the roughness of a surface? And in English, it turns out that English adjectives for rough surfaces, like rough, abrasive, prickly, rugged, rocky, scratchy, bristly, they all actually disproportionately have R's in them. And languages that have trilled R's, like the German sound, are much more likely to have that sound for a rough surface than for a smooth surface, like in English, smooth, oily, silky, slick, satiny, velvety, slimy, gooey, sleek. They all sound sort of smoother than the corresponding rough words. And we've, in this study, extended this to 320 different languages from 80 different language families, looking at texture vocabularies across the globe, and find a really strong effect where R is disproportionately more likely for rough surfaces, really showing you that in this corner of the lexicon, there definitely is a lot of non-arbitrariness, a lot of iconicity. Okay, so, but getting back to iconicity, this loose definition that I've given you, form resembles meaning, is not enough for our purposes. And in a recent paper, we have come up with this definition, and we thought about every word in there. So I'm going to read this out to you, and then we're going to see how some of this pans out in gesture as well. So a word, sign, or gesture is iconic to the extent that language users perceive a contextually instantiated resemblance between some aspect of its form and some aspects of its meaning. And there's a lot of detail here that is, each piece here is actually backed up by empirical research. So some aspect of its form and some aspect of its meaning means that iconicity is always selective. So for example, E, the speech sound that can be used for size, is in that moment only about size. So it sort of hones in on one particular perceptual characteristic. If I'm showing you something small, then I might underspecify the shape with that. Quite like, this is a trivial example, but if I'm showing you a gun, yeah, with a gesture, there's a resemblance between some aspect of the form and a meaning, but clearly there's lots of the gun that I'm omitting in this. For example, trivially, the color, which I can't even depict. But many other aspects of the shape are not actually depicted. So it's always selective. You're taking some subcomponent that you are then taking some form to depict that subcomponent. And then iconicity is contextually instantiated, and it requires cognitive work in order to be perceived. So what that means is that, for example, the same speech sound or the same gesture can depict different things in different contexts. And in particular, this also means that you cannot take iconicity for granted. So if, for example, in a gesture paper, somebody says, oh, it looks like somebody's holding a small pellet, well, what aspect of the shape or the form, you must actually do some sort of work in order to determine that from this gesture, because there's a lot in my hand that doesn't matter in that moment. You're focusing sort of profiling on the index finger and thumb pad, for example. And so I'm actually interested in these design features of iconicity and how they then are used in gesture as well. So the studies that I want to talk about today are a set of very low level. So I'm going to start very low level with gestures for size and shape. And it's a series of experiments. And we're going to go and work from there up towards how then size gestures are used to communicate numerical quantities in real discourse using TV News archive data. And then we're going to go back to experiments and look at how the same iconic dynamics can be used to metaphorically talk about time as well. So we're sort of going to start with the very low level building blocks and then extend upwards towards more high level categories. Now, as a warning, the next set of experiments will be very nitty-gritty, but I hope to convince you that it's really foundational and actually matters for all of gesture research. So we're going to focus on the sort of like very foundational aspects of how do you derive shapes out of a hand. This is work together with Julius Hassemer, and there's 2 papers. It's a series of 6 or 7 experiments that are published in these 2 papers. And this is ultimately based on Julius's PhD thesis, I should acknowledge. So the core sort of theoretical idea comes from him, and then we collaborated on actually testing his ideas from his PhD thesis. And in his PhD thesis, Julius proposes that we need to distinguish between gesture form and articulator form. Articulator form is what is the XYZ of your hand? What is the detailed raw material that your hand is currently doing? And gesture form are the abstract shapes and sizes, the geometrical objects that you're deriving from the articulator form. And that distinction seems very nitty-gritty, nitpicky perhaps, but it's really important because, for example, if you look at me right now, what am I showing you? You probably think that I showed you a line, yeah? But actually, you never saw a line, yeah? You temporally integrated a index finger point across different spatial locations. And then you derived the line as a geometric shape from that. The line is the gesture form, and what your hand is doing is the articulator form. And notice that there's a lot of detail in my hand that you are ignoring. You're focusing just on the index finger and thumb. And this gesture form is then the raw material that can be used in discourse, for example, to talk about an increasing trend of the economy. But crucially, it depends on abstracting away from what my hand is, the detail that my hand is doing. It's kind of like the distinction between phonetics and phonology. So we're going to look at the mapping from the sort of raw material towards the more meaningful components. And that requires cognitive work. So in the case of the line, you need to temporally integrate. You need to actually remember the start point and the end point, and you need to look at the trajectory. But it also requires profiling. So you've seen, for example, that you only focused on my index finger and disregarded the rest. And interestingly, the same gesture can lead to different gesture forms, yeah, so different perceived geometric objects, depending on what aspects of the gesture you profile. So here, notice that the left hand one is indexing a size, because if you're focusing on the index finger and thumb, you then look at that difference. But you can also focus on the C shape, and that will then show you a shape. So you can sort of, depending on what aspects of the hand you emphasize in your mind, you can perceive different gesture forms. And we explored this using specifically precision grip type gestures, so sort of from this general territory. And I just should emphasize here that this is not necessarily a study about these particular types of gestures. The dynamics that I will show here carry over to all gestures, like, for example, showing a line. But we use this because it's a really nice test case of allowing us to explore these ideas. Specifically, if you look at the top row where the pinky finger and fingers 3 to 5 are extended, yeah, If that's the case, then you can either perceive and focus on this one, you can profile that, or you can profile the shape. And then you either derive at a shape interpretation, I'm showing you a shape, or I'm showing you a height. But if the pinky curl is curled in and the C shape is interrupted, the proposal that Julius makes is that then you cannot profile the C shape anymore, and therefore your attention shifts towards the front and a height interpretation should be more likely. And this idea we can then experimentally manipulate. We can use this, whether this is obstructed or not, as a way of sort of shifting between height or shape interpretations. When Julius proposed this idea, to use this as a test case for sort of testing how people derive height or shape meaning as a function of profiling, I said to him, well, first we need to look at whether people are actually doing this at grand scale. So what we did, and so I said, Julius, we need to test that people are actually using these gestures. From now on, I'm going to sort of blaze through a bunch of experiments. Everything in the top right, you'll always see open data and code, so all R scripts and code is available. So I'm not going to mention this from now on. But in this first experiment, Julius went onto the streets of Berlin and showed people a round object like this apple, and then simply asked the question, can you show me the height of this object using just one hand? Or can you show me the shape of this object? And counterbalance which question was asked first. And then we photographed people's hands. So this is static, like, because we're in this case, of course, gesture is dynamic, but here only a static thing matters. And we simply photographed these hand shapes and then had a blind coder who didn't know which question was asked for each pair from each person, look at whether the pinky is more curled in or not. And it turns out that 87% of the time that the height question is asked, the pinky is actually more curled in. So suggesting that people are actually, when they show the height of an object, are using this gesture and curling this in to profile the surface, the index finger and thumb pad. And an even cooler test, I think, this is Julius's idea, I have to say this was really ingenious when he came up with this, was using, again, people on the streets of Berlin, but this time around with 2 dice like this. And they were just placed in the hands of people and they had to throw them up once. And then no further instruction, but then Julius came out with the object and said, can you show me the height of this? Or can you show me the shape of this? And we looked at whether people are more likely to take the die out of their gesturing hand or not, because the idea being that if the C shape matters, then they should be more likely to take it out for that. And if asked the height question, 32% of all people put the die out of their gesturing hand. When asked the shape question, 68% of all people put the die out of the gesturing hand. Now, an obvious concern here is that it's actually harder physically to put the die in your hand when you're showing a C shape. But the fact that this is not the only explanation is the fact that for the height question, actually, some people put the die back into their hand. And that suggests that really what matters here is this difference in profiling. Okay, so now that we knew that people did this in production, we wanted to actually look at these perceptual processes. So we had 3D hand shape from Philip Kreckler, where we have a continuum, a controlled continuum of pinky curl. Yeah, so we have this increasingly curled in. And the idea now is that we show people one of these hands, and then we ask you, does this show the height or the shape of an object? Simple question, yeah? So between subjects design, we have this continuum. You see one of them, and then does it show the height or the shape of a question? And we wanted to actually see some categorical perception here. We wanted to see a sort of stark contrast, but it turned out to be something a little bit more nonlinear, actually. We have an explanation for this U shape, but crucially, the thing that is in support of this hypothesis is that when the pinky is most curled in, yeah, people's perception was that's the only time that you find above chance height responses. So this seems to suggest that as you're curling this in, the attention shifts towards the front. But here we force people to say height or shape. So we did another experiment where we just show people, we printed these hand shapes. and we asked them to draw an object on it. The instructions were, this gesture shows an object, draw the object wherever you think it fits. And it turns out that people are more likely to draw an object between the index finger and thumb if everything is curled in line with this profiling idea that once the C shape is focused, then people focus on the shape. And then an even better test is to use exactly the same hand shape from two perspectives, because that then means that it cannot be something about the different position of the articulators, but it's really about what is the thing that is most prominent to you in your perception. And if you seeing the pinky curl obstructing is the same hand shape, because it's a 3D model, so we can have it exactly the same. If it's the same hand shape, 71% of all people said it's a height. And if it's from the other perspective, only 47% of all people. And that really shows you that what is most prominent to the perceiver at one time point is then shifting whether it's a height or shape response as a function of this profiling difference. Okay, so this is all evidence for profiling as a process that gets you the gesture form from the articulator form. Another important aspect of the definition of iconicity that I've shown you before is that iconicity is always selective. So if, for example, you are showing the shape of something, then you might show a shape that actually fits into your hand, but you might also show something much bigger. Yeah, like, for example, if you're only showing the shape, a round object, I'm talking about a round object that could be of an unspecified size. On the other hand, if you're talking about a height, that should be an object that actually fits in there, but the shape does not matter. So you could put all sorts of objects in there, like we've seen the diamond in the drawing. And so here in this study, we simply ask people, in this case, rather than making a binary choice between the two, can you describe the shape? Can you describe the size? And then look in those textual responses, those qualitative responses, to see whether they're indicators of under-specification of shape when we know that it's a size interpretation, and under-specification of size when it's a shape interpretation. And we now can do this because we know that we can push perception around with this profiling contrast in our hand shapes. So here you have two hand shapes that we know will differ in shape versus size interpretation. So this will be more likely to be size, and this will be more likely to be shape. And in the shape question, we looked at, for example, whether people find it difficult to report shape. This is the word cloud of the responses. So, for example, one participant said the shape is probably circular, probably, yeah, so I'm not quite sure. A cube, or something with a similar height, width, and depth. So clearly emphasizing size at the expense of shape. Or this person said, actually, I cannot determine, as I think the gesture was represent the object's size. And so these markers of insecurity, while they were overall extremely rare, because people just like wrote whatever, were actually much more frequent for the case that we know has the height interpretation. So people were insecure about the shape, and that's a marker of under-specification. On the height question, we got responses like these, and these word clouds for these two gestures. And one of the things we can look at is whether people actually are very precise about the size, and whether they're then therefore less precise about the size when in the shape case here. And that turned out to be quite dominantly the case. So people mentioned, for example, precise numerical values like inches or centimeters when they saw this gesture, and not when they saw this gesture, even though the distance is exactly the same. So this is really also, again, indirect evidence for profiling as well. Okay, so you might say, okay, Bodo, this is really nitty-gritty about this sort of like really fine-grained stuff on this one gesture. Why is this important? I mean, for one is these are the sort of building blocks of iconicity that we often take for granted when we study gesture, where we sort of gloss over the cognitive work that is required, like profiling aspects of a hand shape in order to derive meaning. So I think it's important to understand that process, but also it has ramifications downstream for the linguistic system. So in Lupjan and Winter 2018, we have a paper where we showed that iconic words in this case are less likely to be semantically extended. And the idea here is that because of this selectivity, It is specifically about one thing that makes it less likely to be mapped onto another domain. And I've shown this using a corpus analysis in my sensory linguistics book, where, for example, iconic words are less likely to come up in metaphor. So squealing, which is very depictive of a particular sound, is hard to talk about, like to map onto color in a sort of synesthetic metaphor. Loud color, on the other hand, is something you can find in the corpus. And I've shown using a measure of iconicity that this is the case across different words. And we also know this is the case from sign languages, where if something is highly iconic of one particular thing, it is less likely to be used in a metaphor. So that's just one example of why it's important to notice these design features of iconicity, because they can have effects on how a word or gesture is used elsewhere. Okay, so the methodological point here is that this is a sort of gestural fruit fly, in the sense that even if you're not interested in precision grips, then it's still an extension. It still has sort of, it allows us to explore these cognitive dynamics of iconicity. And the theoretical point here is that iconicity is not just pure resemblance, but it's resemblance that requires cognitive work. You need to establish the resemblance, which requires a sort of abstraction process, similar to how phonology and phonetics interact with each other. Raw material gets translated into some more abstract geometrical shapes. Okay. Now what we're going to look at is how these gesture forms become further used. And specifically here, I want to focus on one study on how size gestures are used to talk about numbers. And that's partially because numerical communication is really important. We very frequently talk about numbers. It's like COVID proves, for example, how important statistics all of a sudden come in public speech. And here we're looking at a corpus study. And specifically, we're interested in how people talk metaphorically about numerical quantity in terms of size, and then how they use gesture and size gestures to make that happen. And we know from experimental research that people think about numbers in terms of, for example, horizontal space. So there's literally hundreds of studies that show that you are faster to press a button with your left hand to smaller numbers, and faster with your right hand to larger numbers. And the inference here is that this is reflecting a sort of mental number line, where small numbers are to the left of right numbers. And it's also known that we think about numbers in terms of size. So we have different mappings available. So one of the more surprising findings, this is one of my favorite sort of findings, where if you grasp for a block, if there's a larger number written on the block, you are going to have a bigger grip aperture automatically, even if the block is the same size. I think that's really surprising. Yeah, like the block is the same size and a number can push your grip aperture sort of automatically away. But the problem is that these are experimental studies. They are sort of often very button pressy and very limited. And we wanted to know whether this actually happens in the real world when people talk about numbers. So this is a study led by our PhD student, Greg Wooden, in cooperation with Marcus Perman, Jeanette Littlemore, and Tini Matlock. And we're looking at TV News Archive data. This is the Internet Archive, scraping all TV news. We are specifically looking at the phrases tiny number, huge number, small number, and big number, and then annotating what gestures co-occur with them. And I'm going to give you a snapshot of this data of how people talk about tiny numbers. And just as a sort of quick disclaimer, I should say, you are going to see a clear bias in this data about who's being represented. But this is unfortunately the TV news. This particular data set that I'm showing you is 2009 to 2013. And there was a clear sort of bias towards male speakers in this particular sample, and also towards white speakers. But that comes with the data. That's not part of our selection process. That is a stereotype that is in the data, unfortunately. But let's have a look at 3 years of American television from the phrase tiny number and this gesture.
A tiny number.
Tiny number. Tiny numbers.
Tiny number.
Tiny number.
A tiny number.
Tiny number.
Tiny number.
Tiny number. Tiny number.
Tiny number.
Tiny number.
Tiny number.
Tiny numbers. Very, very small tiny number. A tiny, tiny number.
A tiny number of, a tiny number of,
The tiny number of
a very tiny number. A tiny number of,
tiny numbers. Tiny number. Tiny numbers.
a tiny, tiny number.
Yeah, tiny number.
Tiny number.
So that's 3 years of American television from the perspective of this particular gesture. I just wanted to point out that with Elizabeth Warren here, how she also curls her finger in, and we looked at that too, and that pans out even in the abstract metaphorical case. But what we did is we looked at 3,200 of these videos. A lot of it had to be excluded because when you work with TV News Archive data, oftentimes the speaker is not visible, the hands are obstructed. So we're only looking at those cases where the speaker is visible and the hands are not obstructed, which ends up being data from about 560 speakers. So more than 500 speakers, which is still better than most lab experiments on gesture. So it's like a hugely, even though the sample is clearly biased, it is a much bigger sample than you would have in, let's say, a university population. And one of the features that we annotated was the hand shape. And we have no gesture, a curved case, which is not very interesting for us here, a closed hand, so that's like a index finger and thumb approaching each other, and an open hand one. And here you're seeing this for tiny numbers, small number, large number, and huge number. And let's first focus on the black bars, which show you that there are very few no gesture cases. So in fact, actually 70 to 80% of the time when somebody used these phrases and the hands were not obstructed and the speaker was visible, they also gestured. And that shows you the sort of dominance of gesture, even in these really abstract numerical talk. And then we had the closed hand, which, if you can see the red bar, is only more likely, relatively speaking, in the case of tiny number. You might say, okay, what's up with the open hand here for small number? Isn't that also small? Shouldn't that be also a precision grip? Well, it turns out that with two hands, of course, you can also do a different size representation, not by this, but for example, by this, which, by the way, also requires gesture form abstraction because you have to sort of infer this distance from that. And so we looked at whether the hands, if they were two-handed, were narrow like this, about torso height or farther than torso height. So we used the torso as a reference point. And you can see that the narrow ones are much more likely for the small ones, and then the wide ones sort of progressively become more frequent for the larger ones. And that is another dimension along which you can show size in the context of numerical quantity. We also looked at inward versus outwards for those that moved, and it turned out that that's actually a huge effect where you're much more likely to gesture outwards for a huge and large number, and slightly more likely to gesture inwards for tiny and small. Now, interestingly, this so far confirms the experimental findings. Yeah, people think about numbers in terms of size, but not everything works in this realistic data. So hand choice, if the gesture is one-handed, is it left or right-handed? Now, admittedly, we don't know whether they're left or right-handed speakers, but even in the sample, we can assume that most of them are right-handed. We find no effect whatsoever of right hand being more likely for the larger quantity. So at least for these expressions, there's no effect of sort of left to right hand choice. Okay, so that was this corpus study. And what can we conclude from this? So, I mean, for one, this is a sort of proof of concept of doing completely open, born open data. Yeah, so like the data is completely accessible, the scraping scripts are accessible, and the annotations are open. And it's a sort of nice way of showing that you can sort of take gesture research out of the constraints of the lab and do this work, which I know, of course, here people in Oxford are also exactly doing. This is the type of work that is sort of, I think, important to be open and more generalizable. That's sort of on the methodological side, but on the theoretical side, I think it really shows nicely that there is evidence in a more ecologically valid context for the idea that people do actually think about numbers in terms of size. And moreover, the experiments are all done on the numbers 1 to 10. It's very sort of constrained, and it turns out that we can find this for all sorts of quantities that are being referred to with tiny number and huge number. So it really shows that this is a general way of thinking about numbers in terms of size, but the left to right thing does not translate from the experiment to the ecological case here. Okay, very quickly, I want to highlight another abstract domain, and I'll finish with this. So another abstract domain, so not just number, but also time, where gesture and gestural iconicity is important for communication. So for those of you in the room who are cognitive linguists, I know that there are several of you who are from that tradition. You will be familiar with the fact that English has two alternative perspectives for conceptualizing time. So in English, you can say something like, we are approaching Christmas, where you are talking about yourself as the agent and who's moving through time, and that's called a moving ego metaphor. But you can also say, Christmas is coming. And in this case, time is moving towards you, and that's called a moving time metaphor. So language evidences these two different conceptualizations of time. So like time on a conveyor belt comes towards you, or you are moving forward in time. And it's been known since the 80s that this is also a contrast in which we think about time, and we can sort of flip between these two perspectives. McGlone and Harding have done a really cool study where if you ask people the question, next Wednesday's meeting has been moved forward 2 days. What day is it on now? So what day is the meeting on now? A new meta-analysis of this research, including McGlone and Harding, has shown that 50% of all people say Friday, and about 50% of all people say Monday. And if you have if you're one of the Friday respondents, you think the Monday people are crazy, and vice versa. But these are two different perspectives, moving forward towards Friday, Wednesday to Friday, or moving it towards you on the moving time perspective, and then it's Monday. And Gemelli and Tversky and Lewis and Stickles showed that you can then actually push people with the gesture to respond either Friday or Monday. So Friday would be, if you say this, next Wednesday's meeting has been moved forward 2 days, or next Wednesday's meeting has been moved backwards 2 days, and then they are more likely to say Monday. So the two conceptualization can be primed by gesture. And that's really cool because the language it's a really cool case of multimodality where like the understanding completely depends on the gesture. Now, I wanted to collaborate with Sarah Duffy, who's sort of, I would say maybe the queen of the next Wednesday question. She's done loads of studies on it, and she's found that both the verbal semantics and the spatial preposition or demonstrative matter. So backwards and forward, yeah, next Wednesday's meeting has been moved forward or backward. And verbs like push or pull or move, they all have different tendencies for Monday or Friday. And so it's like, hey, Sarah, we know this gesture result and you have explored these linguistic effects. What if we pit these two against each other and look at which one wins?
Next Wednesday's meeting has been moved forward 2 days. What day has the meeting scheduled?
So my past self with forward or backward videos in the gesture and in the language. So using next Wednesday's meeting has been moved forward, or next Wednesday's meeting has been moved backwards 2 days. And this was our first experiment. We showed this to people on Amazon Mechanical Turk. Left-hand side, forward language, and then forwards gesture, half Friday responses, half Monday responses. Backwards gesture, half Friday, half Monday responses. Backward language, much more likely to respond Monday. So there was a strong effect of language, and in this case, no effect of gesture. We were like, what did we do wrong? And we were like sort of thinking about this, and obviously like Gemelli and Tversky and Stickles and Lewis, they're really good experimenters. Like, what did we do wrong that we couldn't find this effect? And then looking back at it, we used the wrong hand shape. So we found out, like, if you actually use this hand shape, the problem is that this palm up gesture is often used to present ideas, and it doesn't give you enough to push people along the timeline. It could just be like, oh, I'm showing you something.
Next Wednesday has been moved forward 2 days. What day is the meeting on now?
So now we have this gesture and this gesture to just see whether we can find a gesture effect, just to make sure that we have this. And so the flat one or the push one, and you can see that there's a strong effect of forward versus backward now. So here we actually find this. So the hand shape matters. This doesn't work. but this works. You have to be sort of feeling pushed. So now we had a gesture that worked, and now we can go back to the original idea and pit it against language. So what happens if you have backward language, but actually you mix it with the gestures? There's a small effect of gesture where people are slightly more likely to say Friday if you're moving forward, but the language says backward. If you're saying forward, many more people say Friday, and there's again a small effect of gesture. And we can compare the size of the language and the gesture effect, and the language effect is stronger than the gesture effect in this case. And then we were thinking, well, what if the language doesn't actually have anything spatial? Yeah, maybe then you're not paying as much attention to the gesture. You don't know what the gesture means. So for move, which is spatial language, we find an effect, even if there's no forward or backward in the language. But for change, so it's been changed by 2 days, we find no effect. Interesting enough, this seems to be a very Friday biased verb, but clearly no forward, backward gesture effect. And so we conclude from this that, again, this is kind of the contextually, like iconicity itself doesn't mean anything if you don't have the right language that cues you interpreting the gesture the right way. The gesture form is not interpretable to you if you don't know what it's supposed to mean. And in this case, if the language about time is not spatial itself, the gesture doesn't seem to carry you along the mental timeline. So we conclude that actually you need the right language in order for the gesture to be having this reversal of the Monday, Friday responses. Okay, I am going to skip the last bit because I'm running out of time, but read the paper if you're interested in. There was a social effect as well, where depending on whether you like the speaker, you're more likely to put yourself into their perspective, and then you see Friday moving away from me. But if you are not assuming my perspective and you don't like me, then you're just seeing something closer to you, and that's actually more Monday. So we found that likability modulates this effect. So here we've seen, again, metaphor, this time for time, but using these iconic gestures as their core. And I would say, yes, how does this all connect? Well, it all connects by the fact that it's actually all iconicity all the way down. Metaphor is just a small subtype of the much more general principle of iconicity, which is the basis of which you are seeing the resemblance between this and something spatial. And we have then seen how these gesture forms that are abstracted from the articulator form can become used in number and time domains for communicative effects. And it's really cool how the same gesture then can be sort of polysemous in lots of different ways. So this can be quiet, this can be small, this can be precise, but it's all coming from the fact that you have to first perceive this, you have to profile the fingers and perceive this size thing. And from there, the meaning springs. And to go back to the definition of iconicity, it all depends on context, as we've seen also in the time experiment. The iconicity itself is just not enough. It is all a perceptual process that requires cognitive work, as we've seen in the first set of experiments. And it is a selective process. So if you're highlighting size, you are under-specifying shape, and vice versa. So it's always about an aspect of form signaling an aspect of meaning. And there are many things that you don't show in any iconic gesture. And it's these sort of design features of iconicity that I think are really important to pay attention to when we do multimodal work on iconicity, because that is actually both in spoken language and in gesture. We think that the same dynamics underlie how iconicity is then deployed in communication. Okay. I know this was a lot of stuff that I've thrown at you, but I'm really curious to hear what you think about this. And I'm looking forward to the discussion. Thank you.